Knowing now how to inspect data in Pandas, let's discuss exploratory data analysis, or EDA. We'll apply EDA visually first. We'll consider Fisher's iris flower data. There are 150 observations with 4 measurements from each. There are also 3 distinct flower species. We start with importing pandas and matplotlib.pyplot. We load the data frame and examine it with head. First, let's draw some data with the data frame plot method. We can specify particular column names for the X and Y axes. The result is not all that useful because, by default, plot creates a line plot. For this unordered 4-dimensional data set, a line plot doesn't make a lot of sense. We'll try again, this time specifying kind equals scatter. Let's also label the axes with units of measurement. The scatter plot is better. We'll see later how to distinguish the different species. Individual variable distributions are likely more informative than plotting 2 variables against each other. For instance, specifying kind equals box for, say, the sepal length makes a box plot. The resulting box plot shows the range, the minimum and maximum values, with the whiskers, the interquartile range with the box edges, and the median inside. We'll define these terms clearly later. Another common plotting tool for EDA is a histogram. Here we use kind equals hist. Recall that histograms show frequencies of measurements counted within certain bins or intervals. The result approximates a probability distribution function, or PDF, of the sepal lengths of all the iris flowers. It could be bell-shaped, but it's hard to tell with bins this wide. We can redraw the histogram to get a better sense of the data. Other hist arguments can be passed using the data frame plot interface. For instance, bins is the number of intervals to use in building the histogram. Range gives the extremes of the bins. Normed tells whether to rescale counts to add to 1. Cumulative tells whether to draw the histogram or its cumulative distribution function. More on this shortly. In fact, any matplotlib options can be specified using keyword arguments with plot. Using more keyword options improves the histogram. Here, we specify 30 bins and a range from 4 to 8 and a normed histogram. The customized histogram shows at least 3 distinct peaks in the distribution of sepal lengths. This suggests groups or subpopulations in the data. Another useful plot is the cumulative distribution function, or CDF, computed by adding up the areas of the rectangles under a normalized histogram. CDFs are used to compute the probability of observing a value in a given range, for instance a sepal width between 2 and 4 centimeters. This is easy to plot with the data frame plot method. Intuitively, the CDF evaluated at, say, sepal length 5 centimeters returns the probability of observing a flower with sepal length up to 5 centimeters. A CDF is often a somewhat smooth curve, increasing from 0 to 1. One warning, at present there are 3 different data frame plotting idioms in pandas. For instance, we can use iris.plot, kind equals hist, or iris.plot.hist with the same syntax for arguments. There is also iris.hist. The syntax has defaults that's slightly different in the latter call. These variants work for hist, scatter, box, and related plot functions. Check the documentation for details. That's enough on Visual EDA for now. It's your turn to try some exercises on your own.